Caution: this video is for educational purposes only. We assume no liability for injuries or damage caused by imitating the experiment. Please observe the legal regulations that apply to you when handling chemicals. Different behavior of magnesium and aluminum in dilute acids and bases. A piece of magnesium ribbon 2 cm long is placed in 10 ml each of 2 molar hydrochloric acid, 1 molar sulfuric acid, 2 molar acetic acid and 10% sodium hydroxide solution. The concentration of the acids was chosen so that each solution has the same number of protonatable hydrogen atoms and is therefore comparable in terms of acid strength. The acids react with the metal to form their respective magnesium salts, chloride, sulfate and acetate, with vigorous liberation of hydrogen gas. As the strongest acid, hydrochloric acid dissolves the piece of metal the fastest, followed shortly afterwards by sulfuric acid. Acetic acid takes significantly longer. The carboxylic acid does not fully protonate in water and thus turns out to be the weakest of the three acids. The caustic soda, on the other hand, does not attack the metal at all. In a second step, a double-folded strip of aluminum foil measuring 4 by 2 cm is placed in the same row of samples. Although not significantly more noble, aluminum exhibits a completely different behavior. Diluted acids cannot harm the metal, but caustic soda attacks it. Aluminum is amphoteric, which means that in the presence of bases it does not form a cation, but becomes part of the anion. Sodium aluminate and hydrogen form in this way with sodium hydroxide. Hydrochloric acid only attacks aluminum when heated or in higher concentrations. Aluminum chloride and hydrogen are formed here. On the other hand, diluted sulfuric acid reacts with aluminum only with great difficulty. Diluted acetic acid practically does not attack aluminum even when it's hot. Aluminum has a passivating oxide layer that protects against the effects of diluted acids, but is dissolved by alkali hydroxides. If dilute sulfuric acid is now added to the sodium aluminate solution, a white precipitate of aluminum hydroxide initially forms, which redissolves to form aluminum sulfate when further acid is added. With the alkali metal sulfate that is also formed, the aluminum sulfate crystallizes out to form double salts containing water of crystallization, the so-called aluminum alums. Thanks for watching. If you like the video, please subscribe to our channel. Ratings and comments are welcome. If you'd like to see a specific experiment, post it in the comments and we'll see what we can do.